Okay, good afternoon, everybody. Today we're going to be carrying on our series of past papers. Woohoo! Right. What I've got is the 4H paper from 2008 in May, or June as it's usually called. Same digs, got a formula sheet at the beginning, blah, 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 blah. And we're going to do the first 10 or so questions. I'll see when we get there. Let's see which ones I think we should be carrying on doing. Okay, so now this is worth noting. I haven't actually seen that before. It says, without sufficient working, correct answers may be awarded no marks. Again, you really just got to be able to show where your solutions come from. So, for example, this one here, it is out of 3 marks. You can see that there. If you got the answer right by trial and error, I don't know if you might not get any marks for that. You probably get some, but if you just wrote down the answer, then you might not get anything. So let's do it the proper way. So I'm going to look at this equation and I'm going to gather my terms. So I'm going to take away 2x from both sides so that I get all my x's on the left. It doesn't matter if you put your x's on the left or if you put them on the right, because it all equals out. People like to get the x's on the left, but you don't have to do that if you don't want to. You can get just the x's on the right and have just the numbers on the left if you want. Same thing. That gives us 4x plus 13 equals 2x minus 2x is 0. So I've gotten rid of my x's on the right-hand side, and that's going to equal 7. Now I need to get rid of that 13, so I'm going to minus 13 from both sides, minus 13. And that gives me 4x equals 7 minus 13, which I believe is negative 4. Yeah, is that right? I have no idea. Probably not, actually. 7 minus 13 is negative 6. See, told you it wasn't. Negative 6. And then we can divide by 4 to get rid of the 4. And x equals negative 6 over 4, which is negative, I can just cancel that down a little bit, negative 3 over 2. If you're not sure, shove it into your calculator. So I get negative 3 over 2. Now, what I am going to do is I'm just going to check that answer in these two things here, because I've got x equals negative 3 over 2. All right, so I'm going to say 2 times negative 3 over 2 plus 7 should equal 6 times negative 3 over 2 plus 13. So I'm just going to put those into my calculator. I'm going to put 2 brackets negative 3 over 2, close brackets, plus 7. That gives me 4. And hopefully 6, open brackets, negative 3 over 2, close brackets, plus 13, also equals 4. 4 equals 4, so I know I am correct. There are no other x's which work for that. Next one, solve. It's asking to solve in here. We've got a letter. That's the thing that we're solving for. So I've got y over 5 minus 2 equals 4. If we want to get rid of the denominator, we multiply everything by the same thing. But the key is we've got to multiply everything. We've got to multiply this term, and this term. Okay, so times by 5, times by 5. And I'm going to get y equals 5 times negative 2, which is 10. And that equals 20, 4 times 5. And then I'm just going to add 10. And I'm going to get y equals 30. Check it real quick. Y divided by 5 is, so 30 over 5 minus 2. 30 divided by 5 is 6, minus 2 equals 4. Checked it, it works. Y equals 30. Done. Next question. The diagram shows 2 towns, A and B, on a map. Great map. Very imaginative. Measure the bearing from A of B from A. Okay, so When we're doing bearings, the important thing to remember is that you always measure from north. You have to measure from north, and you have to measure the angle going always clockwise. Okay, always clockwise. Now you might say, but Mr. Williamson, I can't measure that because my protractor it doesn't go around that far enough. Well, what we can do, of course, is we can measure this angle, and I'm not 100% sure what that is. I don't have a protractor on me. That would be 90, maybe. This is maybe about 15 degrees, maybe 20 degrees, call it 20. So let's say that angle there would be 90 plus 20, which is 110. And of course, therefore, this angle here would be 360 minus 110, which is 250 degrees. Now, the thing that they've done here, the reason it's out of 2 marks is one, so that you, because they're asking you to measure the bearing. So one of those marks is actually using your protractor, and one of those marks is knowing that you measure a bearing from north going anti-clockwise. Sorry, going clockwise. Okay, C is another town. The bearing from C from A is 125 degrees. Okay, so I'm just going to get rid of some of this garbage right here because I need that space. Is 125 degrees. So what I'd have to do is measure 125 degrees, which is, I don't know, something like that. Okay, and C is down here. It doesn't say how far it is, but it doesn't matter. Find the bearing of A from C. Okay, the bearing is 125 degrees. So that means that one there doesn't have to be accurate here, because what it's asking says find the bearing of A from C. So what we're saying is we have to go back that direction from C to A. Well, what's the bearing there? Well, we could measure that angle if we wanted, but I know that because this line here is parallel to that line, because that line there is also due north, I know that these two here, they are complementary angles and they add up to give 180 degrees. So I know that this angle here plus, call that x, plus 125 must equal 180. So that means, oops, not 8, x equals 180 minus 125, which is 55 degrees, right? So just checking that, 125 plus 55 is 180. Yep, okay. So that angle there is 55. And I know for the reason that we said before that this angle here going clockwise from C must be 360 minus 55, which equals 305 degrees. Okay. Moving on. The table shows information about the shoe sizes of 20 people. Find the median shoe size. Median, middle. That's what you need to remember. Okay, so let's think about this. What would it look like? This is data, right? So I know that I'm going to get 3 people with size 5 shoe. That's my first 3 pieces of data. Then I'm going to get 8 people with size 6 shoes. 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to get 5 people with 7s. 1, 2, 3, 4, 5. 2 with 8s. And 2 people with size 9 shoes. So if I looked at all of my data, that's what it would look like. It might not be in that order when I'm collecting the data, but fortunately for us at the moment, the question has put it in that order of ascending order. Now, the middle one here, it says what number is going to be in the middle of these. Now, the old-fashioned way and the brute force method is to go one off there and one from the other side, one from this side, one from this side, and keep doing this until we get to the middle. Okay, and I can see that 6 is going to be my median number. Did I do that right? I don't think I did. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, well, I'm going to do it the other way. And I'm going to say, to work out my median median piece of data, I know that I have to have, let's call that my median piece of data M. I know I have to have the same number on that side and the same number of pieces of data on the other side for this to be right in the middle. Now, because I've got 20 people, that means I've got to have 10 there and 10 there. So which piece of data is the mth piece of data? Well, what we do is we do 20 plus 1 divided by 2. And that gives me 10.5, which is kind of like halfway between 10 below and 10 under, right? So you imagine the first 10, and then the second 10, halfway between there is going to be the 10.5th piece of data. And how do we work that out? Well, the first 3 pieces of data are going to be a 5. The next 8 pieces of data are going to be a 6, and that will take us up to, that's the third, that's up to the 11th piece of data. So I know that the 10.5th piece of data must also be an 8. Exactly one of these people has a collar size of 15. Okay. Jean says, if you choose one of these people at random, the probability that this person will either have a shoe size of 8 or a collar size of 15 is this 2 out of 20 plus 1 out of 20. Either a shoe size of 8 or a collar size of 15. Yes. Yes, she is correct, because when it's or, you add. When it's and, you times. And here, the probability, so yes, the probability of picking a shoe size of 8, P shoe size of 8 equals 2 over 20. Remember that our numerator is the number of ways we can get what we want, and that there is the total number of outcome possibilities. Okay, and the probability of a shirt collar size of 15 is, well, it says there's only one of these people. So 1 over 20 is the correct probability for that. So if we add them together, we're going to get 3 out of 20. Okay. Find the value of, next question, find the value of 3 minus 5x when x equals -2. Substitution, I'm going to go 3 minus 5, open brackets, -2, and I'm just going to put that straight into my calculator. 3, oops, turn the calculator on first. 3 minus 5 lots of -2, and that equals 13. Very simple. Multiply out, this is just algebra work. So we know 5 times that and 5 times that. So that's 5y minus 2 times y, 2 times 5, which is 10. So 5y minus 10. Factorize means find all the common factors of our terms. Well, w squared is w times w, and 5 times w. The common factor here is w, so I know that I can turn it into something of the form w times something to give this guy right here. Well, take out w from this term here, what have we got left? We've got w. Take it out of this term here, and what have we got left? 5. So the answer here is w times w plus 5. Question 4, done. Blasting through it. Right. The table shows information about the number of letters delivered to Manjit's house each day. Okay. There are 30 days in June. Calculate an estimate of the number of days in June on which the number of letters delivered is 0. So on any given day, the probability is 0.2. So let's just say, for example, if I had 10 days, that would mean that on 0.2 of 10 days, there would be there would be 0 that equals 0 letters. All right. Well, 0.2 times 10 is just 2. But here it's asking for 30 days in June. Calculate an estimate number of days. Well, I'm just going to do 30 times 0.2, which is 6. So I estimate that on 6 days in June, he will get 0 letters. We don't know when they are, and this, of course, is not accurate. It's just a prediction. Find the probability on a particular day that on a particular day, the number of letters delivered is 6 or more. Well, it's going to be 6 to 10 or more than 10. Yeah. So like we said a minute ago, if it's or, we plus the probabilities. So 0.2 plus 0.1, which is 0.3. 0.2 plus 0.1 equals 0.3. All right, next one is show that. All right, this one you've got to do a little bit of legwork. You've got to be able to show that you know how fractions work. You can't just put this into a calculator and say, yep, it works. That doesn't fly. So instead we need to say, okay, well, 2/3 plus 1/4, right? Well, in order to add fractions together, I need to be able to make the denominator the same. Convert them into similar fractions, okay, equivalent fractions, and add them together when they've got the same denominator. Okay, so 2/3, I can see here that if I times those two denominators together, I can get 12. What I'm looking for is my lowest common multiple. Lowest common multiple. Here it is 12. Sometimes you get a little bit nastier ones. The easiest way is just to multiply those two denominators together. Okay, that will definitely give you a multiple, maybe not the lowest common multiple, but certainly a multiple anyway. So what I'm going to do is I'm going to do it equals 2 times 4 over 3 times 4. So I multiply the numerator and the denominator by the other denominator, plus 1 times the other denominator, 3, over 4 times the other denominator, 3. Okay, now that gives me two fractions which are similar and equivalent to those two, but I can add them together because they're going to have the same denominator. 2 times 4 is 8, and 1 times 3 is 3. Okay, and that equals 8 plus 3 over, not 10, over 12, which is 11 over 12, which is what they've asked you to show up there. Next question is, write 3 to the 8 times 3 to the 6 as a power of 3. I think we covered this in a previous one. If it's timesing indices where the base here is exactly the same, it's got to be exactly the same, otherwise it doesn't work. And it's got to be timesing them as well. You add the indices. So 3 to the 8, times 3 to the 6 equals 3 to the 8 plus 6, which is 3 to the 14. And just really quickly, why does that work? Well, if I took, 2 to the 3 times 2 to the 2, well, that's 2 times 2 times 2, which is 2 to the 3, times 2 times 2, which is 2 to the 2, And now you can see, well, that's just 2 to the 5. Yeah. What if they're not bases? Well, let's say if you had 4 to the 2 times 2 to the 3. Now, you can't times these together directly using this method up here because they don't have the same base. That 4 and the 2 are not the same, so it does not work. However, what I can do is I can rewrite 4 as 2 squared. Okay, 2 squared to the 2 times 2 to the 3. Now, when you've got the thing outside the bracket, another index outside the brackets, what do? You times them. Okay, and that's going to be 2 to the 2 times 2, which is 4, times 2 to the 3, which is 2 to the 7. Okay, so let's look at the next one. 7 to the 5 over 7 to the 2. Take them away. That's a rule. Learn it. Equals 7 to the 5 minus 2 equals 7 to the 3. Done. Next one, it says find the value of n. Okay, well, I know that 5 to the n times 5 to the 3 equals 5 to the n plus 3. And 5 to the n plus 3 over 5 to the 7 equals 5 to the n plus 3 minus 7. Okay, so that's 5 to the n minus 4. Well, up here it says it's 5 to the 2. So something minus 4 must equal 2. Therefore, n must equal, correct, 6. Da, 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 dum. Right, next one. Find the highest common factor of A and B. We look for common factors in both A and B. So I can see there's a 2 in there. I can see there's a 3 in there. And I've got these two numbers here, which have nothing to do with each other. But what I can see is that there's not just 1 2. There's a 2 cubed hiding in A, because it's right there. But there's also a 2 cubed hiding in B, because 2 to the 5 is just, that equals 2 to the 3 times 2 to the 2. So there's a 2 cubed hiding in there. Similarly, there's a 3 hiding in there, right? So I know that if I take 2 cubed times 3, that actually is going to give me the highest common factor. Because these are all prime numbers, you can't make anything, you can't have a larger prime, you can't have a larger common factor because they wouldn't be common in both A and B. So the answer here is going to be 2 cubed times 3, which is 2, 4, 8, 8 times 3, which is 24. And one of the reasons it does that is that it doesn't want to let you calculate this by using, because you've got 5 to the 16 and 7 to the 12. Let me just see if we can do this actually. No, we can't do it on this. No, it doesn't have highest common factors on the calculator. Not even on my calculator. Never mind. So here the answer is 24. Okay. 8. The diagram shows a prism with length 15. The cross-section of the prism is a right-angled triangle with sides 3, 4, and 5. Lovely. Calculate the total surface area of the prism. So, surface area, not volume. We're going to have that triangle there, the triangle at the back, the rectangle on the back, the rectangle on top, and the rectangle underneath. Work out the areas of all of them, and you are done. So the area of the front triangle is 3 times 4 over 2, which is 6. The area of the back triangle is also 3 times 4 over 2, because it's a prism, equals 6. The area of the top diagonal rectangle is going to be 5 times 15, which is 75. You've got the back rectangle, which is going to be 3 times 15, which is 45. And you've also got the bottom triangle, which is 4 times 15, which is 60. Add them all up, and what do we get? We get 75 plus 45 plus 60 plus 6 plus 6, which equals 120, 180, 192. So 192. Just be careful. Sometimes they don't give you the unit there. And just make sure it's writing it in the correct units. Okay, that's question 8. Question 9. Ooh, lovely. Now, you can do this on a calculator if you've got one of the newer ones. But if you don't, not to worry, because there are ways around it. Now, you can, if you want, you can guess x and y, but that's not cool because it's too difficult. There are 2 ways of doing this. I'll show you both. The first way is using a way called elimination. You've got to be able to do elimination. The other way is called substitution, but I'll get back to there in a second. Substitution. Right, elimination means you take these 2 equations and you combine them together to get rid of one of your letters. So I know, let's say if I call this equation number 1 and this equation number 2, okay? If I do 1 plus 2, I'm going to get, actually what I'll do is I'll do it like this, 3x plus y equals 4, and 5x minus y equals 8. And I'm going to add the 2 together, okay? Well, 3x plus 5x equals 8x, plus y minus y, that equals 0. And this here is what we call the eliminated variable. We've gotten rid of it. And here we get 12. So x equals 12 over 8, which is 3 over 2 equals 1.5. Okay. Now, once we've got an x, we can then put it into either of the equations to get our y as well. So I know that 3 times 1.5 plus y equals 4. So 4 minus 3 times 1.5. 3 times 1.5 is 4.5. 4 minus 4.5 equals y. So y equals negative 4.5. Oops. Negative 0.5. So x is 1.5 and minus 0.5. Now, this is actually quite a nice one because I don't think anybody would guess that. But let's do substitution as well. Substitution, I think, is much better. I don't like elimination. It sucks. So what I would do is I would do substitution. Now, from this equation, you got to do a little bit of work to get there, but once you get it, you'll find it really much more powerful and straightforward. I'm going to start with 3x plus y equals 4. And I'm just going to get y on its own. Yeah, I'm going to take away 3x from both sides. Okay, now this is simultaneous equations, and that means the answer of x and y is going to be the same in both of those equations. Same x, same y, and they have to be, otherwise it doesn't work. That's the whole point. So this y here that we've found from the first equation up here, I'm now going to put that y into this equation. So what am I going to get? I'm going to get 5x minus, I'm going to do it in brackets because I like brackets, 4 minus 3x, and that equals 8. Okay, so that y there is the same as that y there. I'm substituting it in for 4 minus 3x. Now I can do some work. 5x minus 4 minus, and a minus is a plus 3x equals 8. 5x plus 3x is 8x minus 4 equals 8. 8x equals 12 plus 4 to both sides. X equals 3 over 2 equals 0.5. Same answer. 1.5. 1.5. Now, this also works and it gives the same answer because we are using correct maths. And then from there, once I've got x equals 1.5, I can use that method over there to find y as well. So substitution is the thing that I like to use more. Could I do it the other way around? Yeah, but I'd end up with fractions all over the place. Because I could say, well, 3x equals 4 minus y, just taking away y from both sides, and x equals 4 minus y over 3. And I can substitute that into this equation here, if I really wanted to. 5 times 4 minus y over 3 minus y equals 8. And I'm not going to do that now because it's already looking disastrously horrible. But it will work out and give me this answer down here. Okay, so not easy, but definitely doable. Oh, last one. Let's do this one here. Question 10. Finish on a round number. The diagram shows a circle with center O and radius 5. Okay, it gives me that information there. ANB is a chord. Remember, a chord is a line that goes through two parts of a circle, 2 points on a circle, and not the diameter, not the origin, not the center. That would be a diameter. Right. AB equals 9.6, so it's just saying what we already know. ONA is a right angle, so that one there we're talking about. Write down the length of AN. The length of AN. Okay, well, I can see that because that's 5, that means that's 5, and that makes that angle there also a right angle. So they're essentially mirror images of each other. So that length there, AN, call that X, must be the same as that length there, which is AX. So I know that X must equal half of 9.6. So 9.6 divided by 2, which is 4.8. 4.8. Calculate the length of ON. ON. Okay, well, for this one here, I'm going to use a bit of Pythagoras, because I know that 4.8 squared plus ON squared equals 5 squared. This is Pythagoras, okay? If you can't remember the formula, it is where? Of course, right here. So you've got your hypotenuse squared is the sum of the other two squared as well, a squared plus b squared. Now, where was I? Now, there, here. So this is just calculator work now. I'm going to rewrite it a little bit. ON squared equals 5 squared minus 4.8 squared. And I'm actually going to do it all in one foul swoop. And I'm going to square root both sides. You know, when you've got something like 2x equals 4, what do? We divide by 2 to get rid of that 2, right? Equals 4. Well, if we've got x squared equals 16, to get rid of that 2, a little squared number, what do? We square root both sides, and that will get rid of our squared sign. So I'm actually going to do ON equals 5 squared minus 4.8 squared, square root. Now, be careful, it's not 5 minus 4.8 squared. It's 5 squared, 5 squared minus 4.8 squared, and then square rooted the entire thing, which actually gives me 7 over 5, or 1.4 if you really want to be a bit, I don't know, decimally. Okay, let's have a quick look at question 11. No, let's not do that. Right, let's leave it at that. Not too bad. Thanks.